and welcome to another edition of Make It Monday here at the Ecotarium. My name is JoAnn, and I'm one of the educators here. So today, we are going to be rocket scientists. We're going to build a Stomp rocket that we'll launch later. First, though, I want to tell you about a very special man who was born and grew up right here in Worcester, Massachusetts, Dr. Robert Goddard. He was born in 1882, and he studied at WPI and later taught physics at Clark University. Now, Dr. Goddard was considered the father of modern rocketry, and that's because he figured out a way to use liquid fuel to send a rocket up into the atmosphere. And it was his goal, his dream, to maybe someday send something to the moon or even to Mars. Wouldn't that be exciting? Now, he did his first test launch on March the 16th of 1926. And this is a picture of Dr. Goddard and his rocket. So, what does a rocket need in order to fly? Well, today, your supplies are going to be a 1/2 inch diameter piece of PVC pipe, and this could be maybe a foot or 1.5 feet long, and this is actually going to be what we are going to use to figure out the size of our rocket, and it will also be part of our Stomp rocket launcher. Now, what else does a rocket need? Well, this is a model of a Saturn V rocket, which is the rocket that sent the astronauts to the moon. And it has a body. Now I have pre-cut the parts here. So our rocket is going to have a green body. And you can make yours either the short way, this way, or you can make a taller rocket. You can make it as big as you want as long as it is not longer than your launcher. And the other important thing is to make sure that it's nice and snug, but not too tight. Make sure it's able to come off your piece of PVC. As I said earlier, this is actually going to be part of your rocket launcher. There we go. So in order to put this all together, we're going to use some masking tape. So has anybody out there ever thought about going to the moon or going to Mars or going to another planet? Yeah, that sounds great. In fact, right now, there is a another rover that's on its way to Mars. The Perseverance Rover is the latest rover by NASA that is headed to the red planet. And it'll join Curiosity, which is currently doing great science up on Mars. But it'll be looking for a little bit different things. And the other exciting thing about Perseverance is that with it is the first helicopter that's going to fly on another planet other than Earth, which is super cool. All right. So another important thing to know when you're building this rocket is, just like with a liquid-fueled rocket, we want to make sure that the fuel doesn't escape. And in this case, our fuel is air. So we don't want the air to escape our rocket. So make sure you don't have any holes. All right, so that looks pretty good. And I can also take this off this piece of PVC. Great. All right, now, what else does our rocket need? Yeah, it needs fins. And these fins help the rocket to go in the direction that we want it to. Now, I have pre-cut some fins here, You can make as many fins as you'd like. You can make them just about any shape that you want as well, as long as it's got a flat side so that you can attach it to the rocket. I usually like to make 3 fins for my rockets. So there is one, and we'll just put this one right here. And fin number 2, make sure I've got the correct side. And I want to spread these out evenly around my rocket. All right, and fin number 3. And like I said, you can put as many fins on as you would like. And that, whoops, down a little further maybe. There we go. Okay, so we've got the fins on, but these are flapping a little bit, so I'm going to put another piece of tape on each of these fins so that it stays in place. And the last one. Here we go. 1, 2, and 3. Great. All right, rocket scientists, engineers. There we go. How does that look? Does it look like that one yet? Not quite. What else are we missing? Ah, the nose cone. Yeah, so the body holds a lot of instrumentation, and the nose cone is typically where your payload would go, or the thing that you want to blast off into space. In the case of the Saturn V, that's where the astronauts were. So our nose cone, we cut from a semicircle, just like that. And you can actually print off all these rocket parts from our website. One of the other things that I like to do with my rocket is to cap it off on the top. So we'll get back to the nose cone in a second. But first, I want to make a cap to go over the top. So I'm going to take my piece of PVC. I'm using this as my template. And then we will make a smaller circle. Oops. It is going to be about the same size as our paper rocket. There we go. Now let me just cut this out and tape it on. So our rocket is going to be powered not by liquid oxygen and gasoline like Dr. Goddard's rocket, but by air. We want to make sure none of that air escapes. We want to make sure it is all used to go to make our rocket go up. So there's my cap. I will tape that to the top. So remember, we don't want any holes. Sometimes you use a lot of tape with this, and that's totally fine. Almost done. There's the other side. 2 more pieces of tape, I think will do it. 1 for over here. And then 1 all the way around. Now, do you think Dr. Goddard got it right the first time? Probably not. Do you think NASA gets it right every time they send something into space? Nope. They only have about a 33% success rate, which means that lots of times it just doesn't work. And that's totally fine, as long as nobody gets hurt. You can just try it again. And with this, of course, you can make as many different designs as you want. Try different kinds of fins, different shapes of nose cones. Here we go. Let me show I'll show you how I put that together again. So it's a circle, and you bring these two ends together and around like that. And then you can make this just about the size of the rocket. Little more tape. Now, if you don't have the cap like I've got, you want to make sure you really stick your nose cone on very well and don't leave any holes for air to get through. So I'm going to take a little bit of tape, and I am going to put this on the inside of the nose cone. Just like that. And we'll put one on the other side. And we're almost done. All right. There we go. Yeah, so the nose cone, not only is this where your payload goes, but the nose cone, you see that shape? That helps it to be more aerodynamic, which helps it to move through the air more easily. And does that look about right? Fantastic. Now, before we're done, I would like to leave you with a quote from Dr. Goddard. It's difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow. So next week, we will build our Stomp rocket launcher, and we'll see how high or how far we can get our rocket to go. I'll see you next week, engineers.